Welcome back, coders. In this video, I will be discussing the question that whether a tree is a binary search tree or not. So let's understand the question. So we have been given a binary tree and we would check whether it is a binary search tree or not. So what is a binary search tree? So a binary search tree is such that whether every node should follow the BST property. Okay, so if every node follows the BST property, then the whole tree is a BST. Otherwise, it is not a BST. So what is the BST property? That every node on left should be smaller than the node, and every node on its right should be greater than it. Right. Okay. So if we are considering 50, then every node towards left of 50 should be smaller than 50 and every node on the right should be greater than 50. Let's understand this. Okay, so what I said is that for a tree to be a BST, every node on its left should be smaller than it and every node on its right should be greater than it. So for leaves, every node, it is true for all leaves because they don't have any left or right. So for every leaf, the BST property is always true. So for all these nodes, BST property follows. Now we'll check for other nodes. So now we'll check for 37. For 37, its left node is smaller than 37 and its right node is greater than 37. So BST property also follows for 37. Now we'll check for 25. For 25, we don't check only 12 and 37. For 25, we don't have to check only 12 and 37, we have to check all the nodes. So all the nodes on its left should be smaller than 25 and all the nodes on its right, that is, we have to check 30, 40 and 37. All of them should be greater than 25. Similarly, for 62, we will check 60 as well as 70. And for 75, we will check 62, 70 and 60, 70 and 62 as well as 87. We will check all these nodes. They all should be smaller than 75 and all the nodes on the right should be greater than 75. And then we'll check for 50. For 50, all the nodes on the left should be smaller than 50 and all the nodes on the right should be greater than 50. So we'll check for 25, we'll check for 12, we'll check for 30, 40 and 37. So if every node follows the BST property, that is, every node on its left is smaller than the node and every node on its right is greater than the node, then it is a binary search tree. So try it on your own and then we will discuss the solution of this video. I hope you tried it on your own. Let's discuss the solution of this video. So for example, you have been given this tree. What we'll do is, we'll work on the post order. So we'll work in the post order. So we'll go like here and then it will work in the order 12 and then 37. Then we get 25. Then we come here, we get 62. Then we get 87, 75 and 50. So we will work in this order. And what we have to find? We have, for this whole tree should be a BST. What we have to do? We have to check three things. Whether it is a BST as a node. As a node, it should be a BST. As a tree, it should be a BST, as well as we have to find the minimum and the maximum value of the node. Okay, so we have to do these three things. We'll have to check whether it is a BST as a node, whether it is a BST as a tree, and it should be greater than the maximum of the left side and should be smaller than the minimum of the right side. Then it will satisfy the BST property. Okay. So how we'll do it is, we already discussed that we'll do it in the post order. Okay, so here it was 37, it was 62, 87 and 75. So we'll check whether it is a BST as a node. We'll check whether it is a BST as a tree. We'll check the minimum value and we'll check the maximum value. We'll check all these 4 things. So for it to be a BST, it should be minimum than the, for it to be a BST as a node, it should be greater than the maximum of left side and it should be smaller than the minimum of right side. Because if it is smaller than the minimum of right side, that is 62, then it is smaller than all of them. And if it is greater than the maximum of the left side, then it is greater than all of these, all the nodes on the left. So for it to be a BST as a node, we just check these 2 things, whether it is smaller, whether it is greater than the maximum of left and smaller than the minimum of right. Okay, so we'll work in the post order and we'll check first for the 12 node. Okay, so for 12, there is no left and no right. So its maximum and minimum will be 12 only. And it is smaller than or equals to, the maximum value and greater than or less equals to the minimum value. So it is a BST. And it is also a BST as tree because all the nodes on the left are also BST. A leaf node will always be a BST. So we won't check for 37 as well because it is also a leaf node. Okay. A leaf node is also always a BST. So this is also a BST and the minimum value is 37 and the maximum value is also 37. Now the work comes for 25. So for 25 to be a BST as a node, it should be greater than the minimum value. So the minimum value here is 12 and the maximum value here is 37. So it should be greater than the minimum value and it should be 25 should be greater than the minimum value and smaller than the maximum value. So it should lie between 12 and 37. So it's lying between 12 and 37. So it is a BST as a node. Now for checking whether it is a BST as a tree, we'll check 3 things. Whether it is a BST as a node and whether all the nodes below it are BST as a tree. So 25 is BST as a node. So first condition is checked. Now all nodes should be BST as a tree. So all the nodes below it, whether 12 is a BST as a tree, we'll check here. Yes, 12 is a BST as a tree. We'll check whether 37 is a BST as a tree. Yes, 37 is also BST as a tree. So 25 satisfy all the 3 conditions. That's why it is a BST as a tree. Now we come here. Now we check for 62. So for 62, we don't have to check anything because 62 is also a leaf node and we already discussed that leaf node is always a BST because it does not have any left or any right. Okay. So our 62 will always be a BST. So we don't have to check, we just write it just as it is. And its maximum and minimum is itself. Now we come at 87. 87 is also a leaf node, so we don't have to do any work. Okay, now we come at 75. Again, we have to check 3 things. Whether first we'll get the minimum value. Minimum value here is 62. The maximum value is 87. And we'll check whether it is a BST as a node. For BST as a node, we have to check whether it is greater than the minimum value and smaller than the maximum value. So yes, our 75 lies between 62 and 87. So yes, our 75 is BST as a node. Now for BST as a tree, we have to check whether it is a BST as a node and whether every node below it is BST as a tree. Okay, so we'll check whether 75 is BST as a node. So yes, 75 is BST as a node, and whether all the nodes below it, so 62 and 87. Whether 62 is BST as a tree? Yes, 62 is BST as a tree. Whether 87 is BST as a tree? Yes, 87 is also BST as a tree. So all of our conditions are satisfied. So 75 is also a BST as a tree. Now we come at 50. Now at 50, we have to check. First of all, we'll get the maximum and the minimum value. Our minimum value will be 25. Our minimum value will be 12. Our minimum value is 12. And our maximum value is 87 here. For 50, our minimum value is 12. And our maximum value is 87. Now, what we have to check? We have to check whether our 50 is BST as a node. So for it to be a BST as a node, we have to check whether it is greater than the minimum value and smaller than the maximum value. So yes, our 50 is greater than 12. Our 50 is smaller than 87. So yes, it is a BST as a tree. Now for it to be a BST as a, it was BST as a node. So now we will check whether it is a BST as a tree. So for it to be a BST as a tree, we'll first check whether it is a BST as a node. So yes, our 50 is BST as a node. Now we'll check for every node below it that whether it is a BST as a tree. So we'll check for 50, we'll check for 75. So 50, we'll check for 25 and we'll check for 75. So for 25, yes, 25 is a BST as a tree. And 75 is also a BST as a tree. So our 50 is also a BST as a tree. So all of these, when our 50 becomes BST as a tree, then we can return true. Okay. So what we, now a question arises that if we are only checking, okay, let's see. Let's take this tree with us. Okay. Now, let's analyze one thing, that we are only checking, this is 87, this is 62, and this is 37. Okay, so this is our tree and we are only checking whether our node is greater than the minimum value of left. It should be greater than the minimum value of left and it should be smaller than the minimum value of right. Maximum, it should, sorry, it's not this. Okay, so our 50 should be greater than the maximum value of left and should be smaller than the minimum value of right. Then it will be a BST. So the question arises that if we are only using the max of left and the min of right, then why are we calculating the minimum value of left as well as the maximum value of right? So this question arises. So I truly understand your doubt. Okay, so let's analyze that. So for checking whether it is a BST as a node, we only need two things: the maximum value of left and the minimum value of right. But to calculate the minimum value as well as the maximum value of the node, right, we need the minimum value of left as well as the minimum value of right. And for calculating the maximum, we need maximum value of right as well as the maximum value of left. So for calculating minimum and maximum, we need both these things. That's why we are calculating both the minimum and maximum of both sides. Okay, both the nodes, all the nodes. Okay, so now the question arises, why are we calculating the minimum and maximum, right? So we are calculating minimum and maximum because we have to check whether our parent also has to check. No, our parent also has to check whether it is a BST or not. So it will require our minimum and maximum. Okay, so we are also children of some node. That's why we have to calculate minimum and maximum of every node, so that our parent can check whether it is a BST or not. Okay, so I hope you understood this. Now let's try to code it. Let's try to code this. Okay. So we'll just, first of all, we'll create a class. Public static class. We'll name it BST pair. And we'll get three things. We'll get the min, we'll get the max, and we'll get the boolean value is BST. Okay. So these are the three things that we need in the pair. Now we create public static BST pair. Okay. Now we'll create the function is BST. We'll get node here. Now what we'll do is, first of all, we'll check whether it is a BST, whether its left side is BST or not. And okay, so we get BST pair left is BST, node dot left. Now we'll check whether it is a BST on the right side. So we'll check on the right side whether it is a BST, node dot right. So both of them will return us three things. It will return us the minimum of left side, maximum of left side, and whether the left side is a BST. Again, our second call will return us three things: the maximum value of right side, the minimum value of right side, and whether our right side is a BST or not. So now what we have to do is, we have to check for ourselves also. So I'm naming it my pair. Whether my pair is, will create new. Okay, now we'll check whether our my pair is BST or not. So how we can check that is, we have to satisfy three conditions. Our left should be a BST, our right should also be a BST, and our minimum, we should be smaller than our maximum of, we should be smaller than our minimum of right, and we should be greater than our maximum of left. So our left should be a BST, should return true. Our right should also return true, BST. Also, we have to check whether our node.data is greater than equals to than our left.max, and our node.data should be lesser than or equals to our minimum of right. So that's how we check whether we are a BST or not. So we check three things: whether our left side is a BST, whether our right side is a BST, and we check whether we are greater than our maximum of left side and whether we are smaller than our minimum of right side. Now we have to calculate our minimum value as well as our maximum value, because we have to also return three things too: maximum, minimum, and is BST. So now for calculating minimum value, we'll just use math.min of node.data, and we'll compare this with the minimum value of left and right side. So math.min of lp.min, comma rp.min. Now we'll calculate our maximum. Max.max of node.data compared with maximum of left and right. Max.max of lp.max, comma rp.max. Now we just return my pair. Now for the base condition, it's very simple. If our node is null, we just return three things. We just create a BST. We'll create a BST pair, base pair, new BST pair. Now what we'll return? We just, in the minimum value, we'll give integer dot max. We'll give plus infinity, integer dot max value. And in our maximum, we'll return integer dot min value. We'll return minus infinity, integer dot min value. We have already discussed this. Why we do this? Because we have to return identities in the base case, right? And our BST should be true, because for null it will always be true, and we'll return base pair. Now we make a call in the main function. So our BST pair P is equals to is BST of root, and we'll just print. We just have to return the boolean value. We don't have to print the minimum and maximum of this pair. Okay, so we'll just print dot is BST. This function should run fine. Let's see whether it works or not. And we are getting a compilation error. Okay, so print line, the spelling is wrong. Okay, now it should work fine. And our answer is accepted. Let's submit this. And now we'll check how our code is working. Now we'll dry run our code and I'll show you one failed test case. Okay, how that works. And our answer is correct. So let's just take our code with us and we see how it is working. So we are taking our code. We don't have to take our base case. We'll just take this part and we have our code here. We'll just put it right here. Okay, now we'll analyze this code, how it is working. So first of all, this is our BST, and now we are checking whether this is a false case, because this will not work. This is not a BST. This is a binary tree. So we are working in the post order. So we come at 12, we check whether it is a BST as a node. So yes, it is a BST as a node, because there is no one on the left and no one on the right. And it is a BST as a tree also. And the minimum value is 12 and the maximum value is also 12. So I'll write it here. And this is node, BST as a node. This is signifying that it is a BST as a tree. This is the minimum value and this is the maximum value. So you should understand it that while dry running, I will write 4 things around a node. Okay. So now we come in the post order of 30. It is also on leaf node. So yes, it is a BST as a node. It is a BST as a tree. Its minimum value is 30 and its maximum value is also 30. Now we come to the post order of 40. Yes, it is a BST as a node. It is a BST as a tree. Its minimum value is 40. Its maximum value is 40. Now we come to the post order of 37. To be a BST as a node, it should be greater than the maximum value of left side and smaller than the minimum value of the right side. So yes, 37 is greater than 30 and smaller than 40. So yes, it is a BST as a node. So whether it is a BST as a tree, we'll check whether our 30 is BST as a tree. Yes. Our 40 is BST as a tree. Yes. So our 37 is also BST as a tree. Now what will be the minimum value? We'll check with 30, 37 and 40. What is the minimum value of all three? 30. So the minimum value of this node will be 30. For the maximum value, we check the maximum of left side, we check the maximum of right side, and we check node.data. Okay, this sentence, right? So the maximum value will be 40. Now we come to the post order of 25. Here, to be a BST as a node, it has to be greater than the maximum of left side and smaller than the minimum of right side. Right? Okay. The minimum is 30, yes. So we are checking with the maximum of left side and minimum of right side. So yes, our 25 is greater than the maximum of left side and smaller than the minimum of right side. So yes, it is a BST as a node. For checking whether it is a BST as a tree, we have to check whether our 12 is BST as a tree. Yes. Whether our 37 is BST as a tree. Yes. So this is a BST as a tree. Now the minimum value here is 12. The maximum value here is 40. Now we come at 60. 60 is also a leaf node. So yes, it is a BST as a node. Yes, it is a BST as a tree. The minimum value is 60 and the maximum value is also 60. Now we go to 76. 76 also a node. So yes, it is a BST as a node. Yes, it is a BST as a tree. Its minimum value is 76 and maximum value is also 76. Now we come here. Now we check for 62. Whether our 62 is BST as a node. So we check whether it is greater than the maximum of left side. Yes, 62 is greater than maximum of left side. And whether it is smaller than the minimum of right side. Yes, it is smaller than the minimum of right side. So yes, it is BST as a node. Now for it to be a BST as a tree, we'll check whether 60 is BST as a tree. Yes. Whether 76 is BST as a tree. Yes. So our 62 is also BST as a tree. Now we check the minimum value. So then the minimum value of 60, 62 and 76 is 60. The maximum value is 76. So now we come to the post order of 87. Now we are here. 87 is also a leaf node. So yes, it is a BST as a node. Yes, it is a BST as a tree. Its minimum value is 87 and maximum value is also 87. Now we come at 75. Now we have to focus on 75. So first of all, we'll check whether 75 is BST as a node. So for it to be a BST as a node, it should be greater than the maximum value of left side, right? But 76 is not smaller than 75. So here our condition fails. So our 75 is not a BST as a node. It is smaller than a minimum value of right side, but it is not greater than the maximum value of left side. So here our condition fails. So this is not a BST as a node. So it will not be a BST as a tree. And if this is not BST as a tree, this will also not BST as a tree. So this will return false. It will return false. And our answer will be correct because this tree is not a BST. Because here our condition failed because all the values on the left side should have been smaller than the node. But 76 is not smaller than 75. That's why this is not a BST. Not a BST. I hope you understood this question. I'll see you in the next question. Thank you so much for watching.